All right, Dr. Behfar, there's been a lot of talk about exosomes. It's impossible for them to be shelf stable. And even if they were shelf stable, in formulation would disrupt them. What are your thoughts on that?
So exosomes are stable and they are stable in formulation, but if we think back on where exosomes exist, they exist in your body. So when exosomes are made, they're formed with a phospholipid bilayer. And if that shell is intact, they're very stable even at body temperature, which is like 98 degrees Fahrenheit. So at room temperature, they're actually quite stable. And exosomes are stable in solution. They're in your bloodstream. We have done this now over the last 10 years and have shown through numerous studies that we have stability for long periods of time in solution. So long as we can make exosomes so that their phospholipid bilayer is not disrupted or broken, they remain very stable in solution at room temperature, even at body temperature. We have done this now over the last 10 years and have shown through numerous studies that we have stability for long periods of time in solution.
One thing I think that confuses people is they see a lot of other products talk about how they need to be deep frozen in the freezer, reconstituted, those kind of things, and I think that might be confusing people. Do you think that's what's making people feel so cautious about exosomes, like shelf-stable exosomes?
Minus 80 freezing is a typical practice for biologics, especially growth factors, because they are very unstable. And so when you either recombinant growth factors or however you derive growth factors, often they do have to come frozen because growth factors have a very potent effect on cells, right? And they can make cells grow in strange ways. So your body controls for that effect by making their life very short. We don't want growth factors lingering for long periods of time. So they're very volatile, and you do want to flash freeze them, thaw them, use them, be done. Exosomes don't work that way. Exosomes is self-limited, it's very short acting, and so naturally these exosomes can persevere until their effect is realized. So I think when people talk about you need to flash freeze exosomes, they probably have disrupted the exosome and they're trying to preserve exosome function through temperature, because they don't really have an exosome anymore. They just have a carcass of an exosome, maybe with some associated growth factors.
And do you think the skepticism from consumers and otherwise makes sense in this field where we have the talk of exosomes are like it's going all over? Do you think consumers should be skeptical, and how would they know that the brand they've selected is a solid one?
I think that it's very difficult in the cosmetic space to have certainty about the product because there isn't any rigor or peer review as people publicize what they have. You can essentially say whatever you want. Our approach has been and will be over the next several years will be to really engage in the peer review process, just like we do with everything else that we study. And so we will publish and work on publishing guidelines and consensus documents that will help the consumer and the providers really understand what are the specific guidances that tell you what an exosome is, what you need to do to prove that you have an exosome, and how you can look at exosomes in products. And then I think having that consensus document will allow the consumers to really look for themselves to see who has and doesn't have exosomes. So we have about 40, 50 papers on platelet-derived exosomes. And in the beginning of every paper where you are describing a function of the exosomes, that first figure is always an exosome figure. It's repetitive, we do it every paper, but essentially you need to show the markers of the exosomes, their size, their content, their potency, and then you go on to show all the other stuff that you've discovered about that exosome. Every time we've published a mechanistic paper on exosomes, we've shown that other people doing science on exosomes do the same sort of thing. So we've published on platelet exosomes numerous times and have shown all these markers. But I think in cosmetics, there isn't a consensus. And so we need to develop that same rigor that we have more on, let's say, the pharmacological and clinical side of the equation now for the cosmetic space as well.
And what is it? The International
Society of Extracellular Vesicles.
They have some standards, right?
Yeah.
And can people use those standards to help them select a cosmetic exosome or?
Yeah, so this is essentially what we conform to when we publish these papers. There's the scientific community and the International Society of Extracellular Vesicles, but even just scientists writ large, when you do peer reviews, there's a standard you need to meet for the scientists reviewing your paper to say, all right, I agree, you have an exosome. Now let's hear what you have to say about it. So that's already established. I think where our work is to take that and apply it to this field that is increasingly leveraging the term exosome and really create rigor around this field as there has been really everywhere else that's used exosome.
Would you say that our articles that are more focused, 11 articles that we did specifically on the cosmetic formulation plated, also does that portion in the beginning where it says these are extracellular vesicles, they're this size, they're characterization as an exosome, are those also in those papers?
In some, usually you put those in mechanistic papers, not in clinical study papers. So if we have a mechanistic paper on platelet exosomes, it's in there. But if it's a clinical study where you're now applying a product that's already established, then you refer to prior papers and you just talk about your clinical study. Like you're not going to rehash that same thing. So you say previously we've shown A, B, C, D. Here we show what it does clinically. So in clinical studies, you don't necessarily need to do it. On mechanistic studies, you do need to do it.
So if we were to point consumers to an article or set of articles that could validate exosomes in plated products, we would point them to the mechanism papers.
Yeah, and there's many that we've published. And not just like my lab, many labs have used these platelet exosomes and have published them.